So we're going to do 1936 now, which asks how you can use a Grignard reaction on an aldehyde or a ketone to synthesize a variety of alcohol products. Alright, so let's do this. Now, if I have 2-pentanol, so let's start by making sure we know how to draw 2-pentanol, 1, 2, 3, 4, 5 carbons, and I put the OH on carbon 2. There are a pretty systematic way by which I can do these retrosynthetic analyses. I find now, the first step, find where is my carbon OH, okay, so this guy here. Then what I need to do is break a bond between that carbon and one of the two adjacent carbons. So here I have two choices, and I'm going to do one at a time. So in the first step I find the COH and I break this bond. That's all I've done here, just broken that bond. Now what I do is say that wherever my OH is, that came from a carbonyl that had a Grignard added to it. So I go back in the backwards direction, make this now my CO double bond. And whatever the carbon is that was bound to that carbon, I just put a Grignard reagent here. Okay, so I have 3 carbons here that I've just broken off. I just, at this little carbon, now add an MGBr. At this carbon, which is the COH, I just make that guy my carbonyl. I can do this breaking the other CC bond as well. So again, I find my COH, I break now the bond on this side. Okay, so that's all I've done here. And now what I do is I take my OH, I bring it back to carbonyl. I take my CH3 and I just attach that to an MGBr to make that my Grignard reagent in this particular case. Alright, I can always in retrosynthesis check myself in the forward direction by seeing if I add this CH3 MGBr to this aldehyde, is that going to give me this product? And it turns out it will, so this works in this case. For B asks me now, B is 1-butanol, how do I do that? Well, primary alcohols, I really only have one choice. It's the same basic idea where I find my COH, and now I need to break a bond between that C and one of its adjacent carbons. Here I only have one adjacent carbon, that means I have to break it here. So this is all I've done here. I've just broken that bond and divided it into 2 fragments. Now, this carbon I just attached to an MGBr. That's pretty straightforward. This carbon that has the OH, I just make that my carbonyl. I would say one of the most common, and this is formaldehyde, okay, so primary alcohols come from the Grignard reaction of formaldehyde with some kind of alkyl compound, okay? So the carbonyl, what I mean by that is that if my product is a primary alcohol, my carbonyl is always formaldehyde. I'd say one of the most common mistakes are people don't really like having this formaldehyde in their reaction, and they tend to assume mistakenly that the carbonyl compound has more carbons than it does, okay? This is just a 1-carbon carbonyl compound, formaldehyde, that adds to my Grignard, with my Grignard reagent, to give me primary alcohols, okay? Primary alcohol Grignard products, again, I can't say this enough, always come from Grignard reactions that involve formaldehyde as the carbonyl component, okay? C now, let's look at C. C asks for 1-phenyl cyclohexanol. So what I do by that, when I try to figure out what that structure is, I first draw cyclohexanol, so that's this compound. Let's see if we can just do that here. I draw cyclohexanol, and then when it says it's 1-phenyl, that means I have a phenyl or benzene ring directly attached to that same carbon. Okay, so phenyl cyclohexanol. And technically here I have 3 different choices. Okay, so if I look at my COH, there are 3 different things bound to it. However, in practice, I can really only break this bond, okay? Because if I tried to break either of these, what would happen to me as a result is I would end up with sort of a case where I'm trying to put a carbonyl and a Grignard in the same species, okay? And that's not going to work well practically. But if I break this bond, then it works very well, because that can give me cyclohexanone, this carbonyl compound here, and now this Grignard product, this phenyl Grignard, which in the forward direction will form the tetrahedral intermediate that picks up a proton in a separate step to give me my desired product. Finally, the last problem for 1936 is diphenylmethanol. So let's draw what diphenylmethanol is first. I could just draw methanol, so that would just be CH3OH, and then put 2 phenols on it, so that gives me this product. Here, when I break a bond between this carbon and the COH and an adjacent carbon, That gives me the same Grignard, and in this case an aldehyde, okay? So secondary alcohols like this one always come from aldehydes, Grignard additions to aldehydes. Tertiary alcohols like this one always come from Grignard additions to ketones. Primary alcohols like this guy in part B are always going to come from Grignard additions to formaldehyde in this case. Okay, so that's as far as going through 1936.